Welcome to Renaissance Charge videos. I'm Rick Friedrich, and here's another Carlos Benitez presentation. This is the Benitez Loving Paths switch 5, 6, and 7. We're going to do actually a combination of these today. So today I have actually gone over the whole patent for the second or third installation, I believe, of the first patent. And we're going to go over the details of that. First I will run this. You can see the battery voltages, which are really hard to follow under load. And then we're going to also watch this. So this is going to be some extra details here, and it's going to be quite a thorough presentation on these particular switches here. I'm calling them the Benitez switches, and the Benitez Loving Path switches 5, 6, and 7. So what we're going to go over here today is a few additional details, combination, and so forth mentioned and implied in the patent itself. Now I haven't shown some of this yet, so pay attention. Now I've uploaded this to my website on the following link, and you'll see the not only the paper that I've printed here, but also the highlights that I'm going over. So you can follow that at the same time I'm reading. And I'm not going to read necessarily every paragraph, but I'm going to go over through most of it. So again, this is the same sort of thing that we're doing with our motors, and we're running the motor between the batteries, and then we're producing an extra charge or power. Here we're running bulbs. In our motors we can run bulbs or batteries. We can run batteries here too. And we're combining another stage similar to this in our third stage process, which allows these batteries to be rotated, which we're going to cover in the patent here. And so that motor over there, the 4-pole, and all of the motors that we use can actually run this way. So you can think of that, it's actually easier to do the motors than these, if people are wondering. These have an unstable interrupter, and we will talk about that also. So in 14.3.11 is the patent, October 9th, 1915, the application date, and it was accepted, the patent edition, on the July 28th. The complete specification, the 5th of February 1916, and complete specification accepted August 17th, 1916. So provisional specification, system for the generation of electrical currents. And then he says, I, Carlos F. Benitez, civil engineer of 141 Acampo Street in Guadalajara, if that's how you say it, Mexico, do hereby declare the nature of this invention to be as follows. The invention which forms the object of this patent of addition relates to new improvements in the system. So that's my highlight there. For the generation of electric currents described in the main patent number 17811, filed July 28, 1914. And in the patent of addition number 5591, filed 14th of April 1915. So those are the details. It's new improvements in the system. Next paragraph. The said system may still be further simplified and improved by the addition of batteries and accumulators. So we looked at last video the earlier switches 1, 2, 3, and 4, which had capacitors in them. And now we are going to be improving by adding batteries, which suitably adjusted in conjunction with the said described system can be charged and discharged alternately, producing furthermore an excess of electrical energy that can be deployed at will for any purpose outside the automatic operation of the arrangement under description. So again, we're going to look at that. There's the switches. 2 battery banks in series for 24 volts, example here. Charging 2 batteries in parallel at 24 volts. 1 and 2 batteries, 3 and 4, and then they can be rotated back and forth. And they can maintain their charge with this system as long as they are doing the extra additional system while they're powering the load. In other words, in the arrangement I use synthetically in combination, 2 groups of accumulators connected in series, 2 groups of accumulators connected in parallel, both said groups disposed in such a way as to utilize the discharge of one of them for the charging of the other, and vice versa. And means for the application of energy produced by any of the methods described in reference to the English patents number 1711 and number 551 or 91, in order to increase the effect of the discharges of each group of accumulators when acting from one to another, and means for reserving the operations of such groups, I should say. Now, another object of this new arrangement is to provide means of the operation of said system using low voltages, condensers of small capacities, and greater facilities for starting. So now, in order, we can use, he goes into 4 volts here. The system is actually, in this patent, a 4-volt system, but we can do it at any voltage. But this system allows for lower voltages than the previous patents, which were capacitors and needed higher voltages. And then secondly, the capacitors can be very small, and we're talking about 1 microfarad, 0.2 microfarad. He doesn't actually tell you, but you can experiment and see very low microfarad. So that is a simplification on the cost of capacitors, but of course you have batteries in that case outweighing that cost. And then greater for starting, in which he's going to talk about his commutator system that allows for automatic cycling of the batteries, which I'm going to make a product that does exactly that. I decided that's the way I'm going to go with doing my battery rotating switch, is in the same way that he did it here. And that's what needs to be developed right now. to make even the motor systems more practical in that way. So the advantages of such an improvement will be better understood by considering the adjoining drawing, which illustrates one method of carrying out the invention. And that is, of course, we're going to be talking about these two switches first. So in figures 1, 2, 3, 4 are batteries of accumulators that once charged from some exterior electrical source will maintain their charges indefinitely in the following manner. So yes, these batteries are in perpetual motion. No, but they are in constant state of charge and never have to be recharged from an external source. Again, once the system is set in motion, the only thing is to repair, in this case really, the contacts, because there is actually nothing else that would wear out here on the spark gap on the interrupter, which we will replace that as well from needing to be replaced. And let's go on. With the connections established and shown in the figure, i.e. when the accumulators 1 and 2 are connected in series through switch 5, switch 6 being open, the accumulators 3 and 4 connected in parallel through switch 7, which is across the two negatives, I think. Oh no, switch 8 being opened. Under these conditions, supposing the 4 batteries to be alike, if battery 1 and 2 has been previously charged from some exterior source, when discharging they will have the superior voltage to the counter electromotive force as opposed by these 2 batteries 3 and 4 receiving such discharge. In other words, if by means of conductor 13, which is going through the system, right, conductor 13 going to the system, the positive pole 9 of battery number 1 and 2 are connected in series, is connected to the positive poles of 10 and 32 of batteries 3 and 4, and both negative poles 11 and 12 of both batteries are connected together. So these are going to be in parallel in that case. An electric current will be established from battery 1 and 2 to batteries 3 and 4 until the voltages of both batteries are alike. Now in this case we're not going to drain them down that far, but this is what he does in this pattern. Of course, the current furnished by the discharge of battery 1 and 2 alone would produce a smaller charge in batteries 3 and 4. Okay, that's what everybody expects from this type of system. That's what somebody wrote me, and they just started arguing with me on YouTube saying, well, that can't be. Why do you think I'm doing this video? If I was just doing something that was conventional, there'd be really no point to this whole video. But that current can be increased by any methods already described in the aforementioned patents number 17811 and 5591. And by these means it is always possible to charge and discharge alternatively each battery 1 and 2 and 3 and 4 from one to another, keeping constant a predetermined charge, and furthermore producing excess electrical energy that can be employed at will. So, if we want to go back to the other earlier patents, we can still do it that means the same way that we're doing it here. With these objects in view, and using an illustration, the arrangement shown in sheet 1, which will be showing these two. Now these are my own drawings in which, actually I didn't draw those exactly, but these are easier to look at. And I'll show you in the video the actual drawings. Then, of the patent edition 5, the condenser 14 is conducted in series to the conductor 13. In the same manner, the primary 15 of an ordinary induction coil provided with an interrupter is connected by each of its poles 16 and 17 to the same wire 13. Now, notice that. In the patent, you do not see the interrupter. All right? And that's, again, the thing that I first said in the first free energy patents misunderstood was Daniel McFarland's patent assumed an interrupter. Just like here, it shows a picture without an interrupter. Doesn't mean there wasn't one, because he mentions it in the patent specifically. So anyway, he goes through the details, how it's all connected up. You can see in the illustration, and you can read the paper online, and I want to move on. So, as a consequence of the passage of this electric current through the primary 15 of said induction coil, all right? So the primary is the main wire that the current goes through first to, and that is right inside of there. The red wires are where they're going through this. So the inner core, so like those are little induction coils there too, and there's an outer, and that would be the inner one. That's the primary. That's the secondary. The primary usually has a bigger winding or a bigger wire to it, and the secondary has thinner wire, more wire, and higher voltage. Now, so as a consequence of this passage through the primary 15 of said induction coil, high tension currents, which is high voltage, usually what it means, will be obtained in the secondary. So the bigger wire, the thinner wire, which being collected in the condenser 22, which in this case I don't even have, because we're actually doing the third, or we're doing this method here. And actually a combination, and either we're actually not going to be using condensers in this one at all. Well, a couple of them we will be. But anyway, we'll finally produce high frequency currents through the primary and secondary of the high frequency transformer. And in this case, we are not going to be doing that today, but we're going to be talking about that. So he's talking about the primaries are actually in parallel of the high frequency transformer, and the secondaries are somewhat in parallel through the spark gap. They're parallel. And that one is a little bit trickier to do because you have to get the primaries probably pretty matched, and it is a higher resistance system when you do it that way. I mean, we're going to have a low resistance primaries on both of these when we do this, but we're actually going to run them parallel to each other. Anyway, they will produce high frequency currents through the primary and secondary of the next transformer. So if we run the one induction coil to a second transformer, such as like this one, but this one's not a high, this is not the right match for that. If we were to run them through them, that's what we would be talking about. And I will show that at a later date when it's important. On the other hand, as much as the poles 28, 29 of this transformer are connected to poles 16 and 17 of the induction coil, said currents will greatly increase the number of amperes furnished by the accumulators 1 and 2. So this is where the system makes up in the secondary transformer through the spark gap. Okay? And the storage batteries 3 and 4, receiving thus a proper amount of current, can be fully charged by these means. The excess of the electrical energy thus obtained can be shunted through conductors 30 in order to be employed at will, as been stated. So here we have 30 and 30 on either one of these. This one is what we're talking about first, and now we're running loads across this capacitor here. Condenser is what they used back then. Back then they called it condenser, we call it capacitor, so forth. So, under these conditions, as the voltage of the one of the batteries is decreasing and increasing in the other, after some hours' work, both voltages will become alike. And then it is impossible to produce any movement electricity from one to the other battery unless switches 5 and 6, 7 and 8 are switched. I've got a typo here. Speaking in other terms, inasmuch as batteries 3 and 4 is charged and 1 and 2 is almost discharged, if the functions of said batteries are now reversed, the original conditions can be established once more and the same operations repeated entirely as before. So forth, switching them back and forth. Now here's a key point. When the resistance offered in the passage of electrical currents by the primary of the transformer 15, see here's he's calling the induction coil merely a transformer, right? Induction coil is a transformer, so you got to get familiar with that. So if the resistance is not too high, it is possible to simplify the former arrangement, obtaining the high frequency currents directly from the same coil 15, in which case the whole transformer and all of its parts are removed. Under these conditions, I didn't read that exactly, but just to make it easy to understand, under these conditions, the breaker or interrupter employed in said induction coil, right here, right, acts as a spark gap. And the condenser 14 discharges in the form of oscillations through the primary of the same coil, thus directly increasing the amount of electrical energy furnished by the accumulators. Dated 9th day of October 1915. That is the first part. So that's actually switch number 5, right? And 6. So we can reduce this all together and go to this arrangement, which is basically what I'm showing when I've showed before. And I want to do a combination now of that with switch number 7, which is the remaining part of this paper that are actually separated in time, but are submitted in the same paper here together. So, complete specification, system for the generation of electrical currents. He introduces the same thing again, and he said, this said system may be still further improved, and he goes on. The current given by the battery of accumulators connected in series is increased when discharging by the electrical oscillations. These are just going over the same sort of thing. I'm not going to read all of it because you can read it yourself. I'm just going to go over the highlights. So again, he says, obviously, the current furnished by the discharge of battery 1 and 2 alone would produce a smaller charge in batteries 3 and 4 if some extra energy were not added to the normal output of said batteries 1 and 2. So he's actually looking at increasing the output of batteries 1 and 2 in that statement, which is interesting. And that's what I said before. In this particular system, he does it differently. The connection goes to the negative terminal in between the batteries, right, of the capacitor. And that is really interesting. And we demonstrated that in an earlier video, and I'm actually not going to do that today because we're going to do something else. Now, he goes over all the same details, slightly different words in a couple of paragraphs, but then he goes into the particular details of this new system. Now, he says, with this object in view, and in order to illustrate this point, this particular point, said batteries 1 and 2 and 3 and 4 have been connected respectively through switches 5, 6, 7, and 8 in such a manner that by reversing the position of said switches, the connection of said batteries are easily reversed. Okay, we talked about that. But in practice, far better results can be attained by the use of the commutator shown in the adjoining sheet number 2, as will be fully explained. So now, this is the commutator system that he has, and what he's getting at, as far as I can see, is not an addition of extra power, but better results in the way of making it more efficient to switch the terminals. To go and switch all these batteries around and have all those multiple switches that you have to switch is a nuisance. And this is a better system. Now this one also allows, which I didn't read all the details, of adding batteries in higher series parallel configurations. In other words, so say these were 12 volt batteries, so there would be 36 volts going into, say, 12 volts. And there's a 24 volt difference in running voltage across your load there. And, or actually not, 24 volts initially. Now, other than that, I don't see anything in his, because this is not spinning rapidly or something like that, then, which in case would be the Tesla switch, which we've already shown, kills the batteries. I don't see what he means by far better results in the way of energy production. Just practical results he's talking about in the way of switching the batteries around, because that's really what he said. He wasn't referring to efficiency there, like he says elsewhere in the patent about other matters. All right, so now jumping down, he says the same sort of thing about doing, he's just going over switch 5 and 6 again, and then he proceeds to get down into, so like I said, these really all go together, and what we're going to do here is the same thing that can be done here, with the additional benefits to this system. So he talks about the cylinder turning around furthermore, and condenser 14, now this is this condenser, in this case the only capacitor in the system right now, like I showed before in a previous video, is connected by its usual pole 52 and to pole 17 of the primary of same transformer, and its other pole 53, instead of being connected back to the contact stud 50 of the breaker, as is generally the case, is grounded through wire 54 and pole 56 of the commutator. So it comes back here and goes to the negatives of the batteries and to the ground. Now, he shows in the other, that's usually the case, and I mentioned this before, we talked about that at length before, and I demonstrated the next part of the statement that he says here. Under these conditions, when the circuit is broken by the interrupter, right, the condenser, this condenser here, is charged and immediately afterward discharges via primary 15, right, of the transformer, secondary of the same transformer, wire 55, pole 48, path 41 of the commutator, and battery 3 and 4 in parallel. So it dumps the charge across the battery. So it discharges in parallel. So as a consequence of the passage of electric currents produced by this discharge through primary 15 of the transformer, induced currents are produced in its secondary, right? And one of these currents, the inverse passing through pole 19, is immediately utilized for the charging of the same said battery in parallel. The direct current that is produced when the discharge of said condenser 14 is finished, passing through pole 18 and entering the primary 15 through pole 16, produces new charge in the same condenser 14 that again discharges in identical manner, and the same phenomena are reproduced several times in the beats or intervals of breaks and makes produced by the interrupter. So we saw that in an earlier video with the oscilloscope, that there's quite a bit of oscillations between the makes and breaks of the contacts. And so we have a duplication of energy there at that time, kind of like a ringing tank circuit. On the other hand, if poles 56 of the commutator are not grounded, right? That same wire coming back through here. If they're not grounded, each time the condenser 14 receives a new charge, the neutral fluid of its outer coating is influenced through its dielectric, and an induced electric current is forced to move via wire 54 and pole 56. In other words, this extra energy increases the normal output of said battery 1 and 2. This is the input battery. And so we're going to see that in a minute, even without doing that with this system, how this particular battery can have an increased voltage on it while running and charging up these batteries. So this is where I've gotten to the place where we can keep the primary battery charged, both in my motor systems and in this system, and keep charging this. So the only thing that we've got to do is actually have a load and discharge these batteries once in a while. And otherwise, once they become equal, well, this would never get up to 24 volts, but could get pretty high. So what's interesting is with this huge big induction coil with its 50,000 volts, which is way out of specs for this patent, you can see the results. And now I'm not confident that that's the best thing for the battery, that high voltage and you know, dealing with that, but you'll be able to see it work anyways. So that's an important point where we can actually increase the input and have more power over these batteries than what the battery is actually furnishing. And that coming from the unique arrangement of the capacitors, or what I'll talk about in a minute with the way we have it set up. So by these means, the current given by the accumulators, the batteries, connected in series, is properly increased by the induced currents produced in the secondary of the induction coil. So again, that's where the goods happen, in the secondary coil in combination with the spark gap. Because we have this action, oscillations going back and forth, charging each coil, one coil to the other coil, charging up the cap, and so forth, this ringing oscillation. And then, and the accumulators connected in parallel, receiving thus a proper amount of current, can be fully charged, while the first battery is discharging. However, as the first battery is discharging, its voltage is progressively decreasing. Now here's a really interesting statement. And in order to maintain the circuit a given current for the charging of the second battery, the resistance of the same said circuit must be accordingly reduced. Now, I read that over when I typed this up, and it's ambiguous. It seems to me that he's hinting at, it's one of the only ambiguous things said in all these patents of his. To me, he's not just pointing out that this battery is discharging, but he's giving you, in the second part of the sentence, in order to maintain the circuit. I don't believe he's talking about merely just charging up these batteries enough to keep enough power flowing in the whole system like he's talked about repeatedly before that point. He's talking about, first of all, this extra energy coming into these primary batteries, right? 1 and 2. And then he adds this statement, however, as if, however, as the first battery is discharging, its voltage is progressively decreasing. But, or he says and here, in order to maintain the circuit, a given current, so adjusting the interrupter is what he'll say in a minute, the resistance of the same circuit must be accordingly reduced. Now, that obviously means as this one gets closer to this battery voltage, you can adjust that down there so it still runs till really close, because it's going to run on really low voltage. But I'm wondering if he's talking about just keeping these batteries charged altogether in that statement. Maybe it might be a little bit reaching to say that, but that's what I've experienced. So You know, that's what he could have been kind of, by putting that all together in the same paragraph, following the other paragraph. All right, in order to attain this result without touching the wire, the back contact of stud 50 and the breaker can be adjusted in order to secure a proper resistance through the interrupter in accordance with the decreasing voltage. And in this matter, it's always possible to maintain a given current in the circuit until the very last limit of energy in the discharging battery is attained, like I just said. So that may be all that he's trying to say in there, but we're going to see in a moment what happens when we add additional process here. Better results in every respect can still be obtained by the use of a closed core transformer combined with an electrolytic interrupter. Since with these interrupters practically there is no lost time in the intervals between breaks and makes, and the resistance of such devices can be easily adjusted at a distance whenever the operator may desire. Now, I talked about this before, and this is going to be a big part of my research and this project. And first of all, transformers. We all know there's more or less efficient transformers. The transformer in this particular arrangement is less efficient than these types of transformers. And then of course we also have our toroidal transformers, and then just different more exotic transformers that people have developed over the years, including the pancake coil transformer and so forth. So now the interrupter. Okay, so the interrupter is inconvenient because the parts wear out, and when they went to do these processes in higher amperage, they had to have something more stable because it would easily pit and wear out and need constant servicing. So they developed different types of interrupter systems and eventually went with these electrolytic, so fluid interrupters, where for example they had a tube filled with mercury, and then they would adjust the points, the distance, and then literally the bubbling in the electrolyte would create the oscillations as the current passed through. And then it could be adjusted remotely, in other words, farther away. And so that was desirable, and then you could have your spark gap anywhere if you don't use that as the spark gap, anywhere you want it. So that, when I look for doing that, usually it's still being done today in certain processes, but it's not readily available, and there's some maintenance involved with it, and it also has to run at higher voltages, and like I think at least 30 volts in that, and also I think there's explosive possibilities there as well. So we don't need to do that anymore. Like when we get into the final patent, you'll see that we won't need to do any of these interrupters or electrolytic interrupters. We can go straight to the neon sign transformers or various other methods similar to that, and then create our own spark gaps. But anyway, this is the first stage of understanding these processes, so that's why I'm going over them. Now, he goes on and repeats it once they switch the batteries around, and then he goes into saying, in other words, the working conditions can be thus completely reversed by the simple operation of the commutator, and a continuous current can be maintained through wire 55, in which the primary 57 of an ordinary transformer or any other suitable device can be inserted in series in order to profit the surplus of electrical energy thus obtained without impairing in the least the running of the mechanism. Now, that I jumped ahead on. So you can see here that I have actually two transformers this time, and that represents this particular transformer 57. I don't have it listed on this diagram, but you can see it here. Transformer 57, and there's the original. And so instead of having it like we had in this particular one, across the capacitor we're running our loads. Now we have the benefit of running a transformer there, and then, or any kind of resistance, and then we can actually run loads off of that, which, as he says in this patent, is an improvement from switches number 5 and 6, right? So, but since he said this, a continuous current can be maintained through wire 55 again. There's wire 55, which in this case is going across here, and in which the primary of an ordinary transformer or any other suitable device can be inserted in series in order to profit the surplus of electrical energy thus obtained. And it says, without impairing in the least the running of the mechanism. So this is where, again, I say in my motor, da-da-da, we run the motor in series, right? Series with the batteries for free. And people say, well, that can't be, you got a loss of resistance, blah, blah, blah. Not with the disruptive discharge and the oscillation. That's why this whole the whole purpose of this patent, people. So now what I'm doing is I'm running both of these in series with each other, and you'll see the difference when I run the one or I run both of them. So I'm going to run it with both first, and then we'll go back to the single, and you'll see the difference. And so, what do you think will happen there? So if you get this right, you can add as many outputs as you want. Now, it would be a little bit more than just adding more outputs here. But once you start thinking, how could I increase this? I might say it at the end of this video, or I may not. I think what I'll do is I'll pose it as a question and see if anybody figures out what could be done. So, before we go and demonstrate it, I'm going to read one last paragraph here. Obviously, means can be disposed in order to obtain an automatic operation of the commutator from time to time in accordance with the capacity of the accumulators employed, and in consequence, for a given weight of batteries. Now get this. This is one of these questionable sentences. This is actually the ambiguous statement that I'm not entirely sure of. For a given weight of batteries, greater power can be secured by this process with smaller capacities than with greater units, since the same 4 volts can be easily obtained from a 60 amp hours accumulator as with a 10 amp hours capacity. So, reading that whole sentence together, he's talking about rotating this around from time to time according to the capacity of the accumulators, and then in consequence, for a given weight of batteries, greater power can be secured by this process with smaller capacities than with greater units. All right, that's the statement. Wait a second, I thought I need bigger batteries, more amps. Since the same 4 volts can be easily obtained from a 60 amp hours accumulator as with a 10 amp hour capacity. So in other words, it's not amperage, people. It's not the amperage that's giving you the goods. It's the other side of electricity. Notice, he's saying that, okay, these are 20 amp hours. So with smaller, we're still doing the same process, the same voltages. And they're still driving this whole same system. But I can still produce the same amount. He says, greater power can be secured with smaller capacities than with greater units. Now he said at the beginning of the patent he can use smaller capacitors than before, but that's not what he's referring to. So that's very interesting, and that goes along with my whole theory of how this whole thing works. And let's go into an interesting demonstration here. So the batteries have settled down now to, I have been running these and they were sitting at that voltage. Hold on a second. They were sitting at this voltage prior, so now they're rested and they're back down. Turn on the amp meter. The problem with this amp meter, as I said, is that it's affected by where it's placed. But once we leave it in one place, it should stay pretty much the same. So now let's look at this and describe first of all what's happening. So what I have here, and I'll describe here in these papers. So what I have going here is this switch 7, and here is the primary and secondary induction coil, the interrupter. I'm not using this capacitor like I showed in the previous videos. And we have this arrangement with these transformers in series with each other, coming through these wires. So going from battery bank 1, 2 through the induction coil primary, actually secondary, really, the secondary is always connected up. So actually it has, well, I've disconnected it so it hasn't been discharging, but. And then what we have is it going through the transformers back here. And then what we did here is I was trying to do a combination, but this particular demonstration I need a different transformer than I have here to do this demonstration. But what we're going to do is this addition to switch 7. So we're going to add the extra down here, but I couldn't do it with this one because there's such a huge voltage difference between this secondary and this secondary and this primary and that primary. So what I did is I put the secondary out of here going through to a high voltage capacitor, which was actually unnecessary. So in this configuration down here with the spark gap, going through the spark gap to the secondary. Now the secondary on these ones are only on these terminals, they're not down there. And then it didn't work because of the vast difference. And so what I did instead was left that hooked up like that, and then I'm just going to run these two in parallel. So the primaries of both induction coils are going to be in parallel. And I tried to run it and bypass the interrupter, but on that particular coil it won't work. But this one gave me such favorable results that I want to show you. When I run this, first of all, by itself, it's drawing 52.052 amps, and you can see how much it brings down those batteries, and they kind of vary a little bit here and there. So anyway, that's that system. It's charging up, it's running the batteries. If I disconnect, it's drawing a little bit more actually on this particular setup. Now watch what happens when I add look how much more it's drawing. Now, I don't have it like I had it before. Oh wait, because I don't have the spark yet. So what happens is these meters start to go crazy on me. But my point is, now, I had it a little bit better than this before, so I'm wondering. See, that's funny because this is still arcing here without a connection. There we go. That's a little bit more stable. Except, seem to have lost. Oh, I know what happened. Yeah, see now we're way out of what I had. See, this one's a very unstable setup because of the spark gap here, but anyway, we wouldn't want these flickering lights like this, but they're very bright right now because of my particular spark gap here is a problem. So why don't I do this? I'm going to go back and try something here. And disconnect all these. And connect this up. That won't work. Oh, I see. One wire. It's not. Well, it's interesting that that doesn't go without it. See, so that's the one by itself. And like I said, I've got a very slim spark gap on there. So quite high amperage there. So if I get an interesting spark gap here, we could see the primary actually goes back up. That's what I was trying to show on this whole thing. I had it where, now we're talking about 500 milliamps showing going into the system, but look at the primary battery. Now it's undercharged, so it's different, but what I'm trying to say is under the right circumstances, that will be its actual voltage, its resting voltage. So we have obviously the equivalent amount of light here in these bulbs. I hope I've been blinding everybody in this video. But you can see the voltage on the charging battery. Of course, it's not going to be characteristic of the actual voltage, especially on the charging battery, but so now it's turned itself up. So we have very little there. So this is where he was talking about where we can get down to very slight adjustments here. And if you have the other kind of interrupter, it makes a big difference. So yeah, so this isn't quite the demonstration that I wanted to portray here on the system, but it is showing you some things. But you can see this one draws a lot more power. This one draws a lot, this one's a lot less efficient than this one. So you want some spark gap, but not too much. See, it wants this bulb. All right, so let's go into what I said before and run this one. So you can see the voltage on that one is pretty much resting 25.1, and this one's gone way up. And like I said, these high frequency systems can stabilize themselves, in which they actually end up returning to the same voltages. And so what I want to do now is show it running with one, well, just forget about that transformer right now, or that induction coil. So we're at 55 milliamps, and it went down to 39 in that case. Now when I had it hooked up prior to this video, it was running the way I wanted it. It actually didn't change when I had them both running like that. But let's run it now. Or let's take off this one and see. So now let's see, it's drawing quite a bit more now. So yeah, I didn't really demonstrate it in this video very well like I wanted to, but if you follow what I said, you can get that. I don't have time to do all that. I apologize for that. But anyway, we can add more loads on this if we get more bulbs here. And then see same thing. Now in that case the bulb shares the load, it's not as bright, they dim a little bit in that. So what we could do is run the bulb in series. In that case. So that actually reduced the amp draw, it seems. So if I short it out, yeah, shorting it out, running the battery in, or the bulb in series with the coils, did not change the brightness of the other coil, and did not draw any more amps, I don't think. Oh yeah, a little bit more. Actually, no, it draws more when I short it out. But then it draws more energy there. Yeah. So anyway, I probably should have used another induction coil, one of these other ones instead. Might have been better. We could try another one here. See what happens with this one. And we'll run this one. If we can have enough wire to reach it. Hopefully this one works. Oh yeah, that one runs nice. Much higher power though. And I'm not using the secondary at all. But we have a lot of brightness there. Whoa, can't even look at it. But yeah, we're drawing quite a bit more energy here. 10 times more. But if I don't have a load on there, it draws quite a bit more. Anyway, could try this one again actually and see what happens. You gotta be careful that that doesn't just stick, otherwise you get in trouble. Whoops. See, that one's stuck. See, this one's got a... This one's a much better interrupter on that. Now this one has gone way up in power level. Trying to run these together is difficult. See, now I'm just drawing the batteries down too much. Oh wait, so you can see this battery's been boosted way up there because I basically had a short across the coil. And oops, I still had it. So it's not going to give you very much of an example today on this one, but it gives you an idea of what we're talking about in this patent. So again, to go over what we're doing, ideally, what I'm trying to get at with this whole video is we can combine all three of, well, these two systems, switch 5 and 7 together to multiply. And so I asked the question, since I didn't give you, to me, a satisfactory demonstration, I'm just going to say it. So I want you to pause about it and think about it. Don't just be spoon-fed here. What would it take to multiply this process out? If this gives you a hint that this is a gain over this, and he says you can do this to simplify it, but that wasn't a gain over this, obviously. If this is a gain over this, then why would you waste your time doing that? Think about it. Now, of course, he did talk about this afterwards, but like I said, there would be no point in even going into this. I think because the spark, like he says in the last patent, that multiple spark gaps is an advantage. So that would be like 2 spark gaps here with the interrupter. There would be still a gap there. So now, if this is an advantage, then doing that here would also be an advantage. It would be a multiplication. So now, in which way would you find how to increase this whole thing? What would you do? Now, we talked about adding 2 transformers here, and there's a limit to that, but I did draw something up, and that's not really what I want to show you per se, but so if you see this, these are parallel arrangements, 27 and 15. 15 and 27 are in parallel, and these ones are also somewhat in parallel through a spark gap. So if you actually duplicated this whole system again here and paralleled out another spark gap and secondary, then both would be producing their oscillations independently of each other, both influenced by secondary of the primary induction coil, and you could multiply that out with multiple spark gaps. That's what the meaning would be. So what does that remind you of? In my motor circuits where we have multiple strands, multiple switches, multiple transistors switching. And if you think about the transistor being the switch, it's the same as the spark gap. Spark gap has a lot more potential, although you can oscillate these transistors as well. And but I don't think you're going to ever get the same kind of results with transistors as you could with the spark gap. So you can see the primary battery is bounced back up to it's pretty much original voltage. I mean, it will still go back up to 12.23 is, it was just right at 2.3 going back and forth initially. And then you can see this one was at 1177. It's coming back down. But that's the point, is these batteries will stabilize, come back with this sort of system, and we can run our loads at the same time. And that's the great part about it. So to recap, what we showed here is a couple of things. That you can do a combination of additional transformer processes in combination with the main transformer induction coil. You can put these in series with each other, and that's an improvement. Now, he did talk about the resistance being higher on this arrangement. Right now we've got fairly low resistance, and that's why I ran into that trouble. And if you already have high resist or low resistance there, you're going to be drawing a lot more current. Even though this was a small one here, it evidently had like this. You know, it's small. That's pretty thick wire. That's like probably about 20 gauge wire, or 19 or something like that. I'd say about 20 gauge wire on there, and there's not much of it, so that's pretty low resistance, and it's going to draw a lot more current on it. So in order to do this, you want higher resistance here, and then of course, like I said, you've got to match your secondaries. So that's the that's what we're talking about in this video, is multiplying this out, and a couple other points that were mentioned in the patent itself that I went over. And like I said, we'll go on to the next patent, in which we need 2 battery banks instead of 4. And that way we reduce the battery sizes, and we can actually have smaller capacity batteries. As I said in this video here, that what he hinted at was you didn't need big batteries to do this process. What you're talking about is either running at a higher voltage with more batteries, or we can do this process. Eventually I'll show where you just have one little battery that keeps itself charged, and it does the final stage process, or the see, there we go, 25.3. We're back to the same input voltage, even though we were running even at times 500 milliamps for a good bit of time here, and dead shorted for a little bit of time, and we're back to the original voltage with having charged these batteries and then run these loads. So But anyway, eventually we'll have the one battery system in which I'll show this, where it creates the process, the switching, and then it also runs a load of whatever size you want. And that is just a matter of improving on this process. So this is a great learning tool to start off with in a safe. This is why I'm bringing this up, because I want to teach you guys how to be safe. And I want you to succeed without wasting your money on parts. And you might think, oh, I don't want to buy an induction coil, Rick. You know, I don't want to spend that money. Just come on, just tell me the answer, or give me the product. And you know what? I may not be able to have a product in the future. You know, something might happen to me. Who knows? But I wanted to teach you these things because nobody bothered to teach you this for 100 years, except Bruce Perrault gave us these diagrams 12, 13 years ago or whatever, so he did. But the point is, there's been no replications on YouTube of this. In the free energy community, there's been very little activity about this. And so I wanted to show you this before you try and go to the last stage of the Benitez patents. Or because like people are trying to do that with the Don Smith systems, and almost everybody is failing, or they're getting very minuscule results. And why is that? You know, come back to square one, see how understand the processes, how they work, and then move forward in that to the next level. And then you'll be able to figure out how to do a higher voltage level. And then you have to get into all the details of fine-tuning, matching parts, and so forth. Although it's not as hard as you think, you may think. So we'll get into that. And I think that covers it pretty much for now. We'll get into future videos where I have this better set up, different combinations, where we have you know, systems side by side. We'll get the different exact coils here lined up, and we'll show you that. And then we'll get into electrolytic interrupters, and not having to get these induction coils, but they're great. You can get them everywhere still from eBay, and they will teach you a lot. And then like I said, the motor systems, like I have over here, that motor system is an easier way than doing all of this. Plus it gives you mechanical power, which just gives you none. And that's a lot more stable, and it's easier to control than this. So I know a lot of people like solid state, but in this case, it's not quite solid state, is it? It's a mechanical part as well. And so there'll always be the motors, we'll always be selling those, and we'll get into doing a kit like this, because like I said, we have to have something at the basic safe level, which the motor kits are, and these. But once we get into the higher production, we got to get into these zinc plates and putting our spark gaps in there and so forth. And then we can get back, or then we can do some real power, right? We can really crank out the kilowatts, and I know people are asking for megawatts and gigawatts right now, and that's a tall order to do. So thank you for watching. I appreciate any support on this. Give me a like if you really like this video. If you don't understand it, watch it again. Thank you.